Hi, everyone. Welcome to Cloud Next 2021. We're so excited you're here with us on Developer Day. So, we're going to be showing you how you can incorporate Google Cloud's AI and ML offerings into your app or service. With our APIs, it doesn't matter what platform or stack you're using, we've got you covered. Today, specifically, we'll be talking about Google Cloud Document AI and how to use it with our serverless offerings, such as Cloud Functions for business logic and workflows for orchestrating your services. But before we get started, who are we? My name is Srivastava, and I'm a developer advocate in New York, focusing on AI and ML, bringing these services to developers around the world.
Hello everyone, I'm Guillaume. I'm also a developer advocate at Google, but I'm based in the Paris office and I'm focusing mainly on our serverless technologies like Cloud Functions, Cloud Run App Engine, and also our orchestration solutions like workflows.
Awesome. So let's start with why we're here. It's Google Cloud's mission to help you innovate faster towards your business goals. And there are several different ways that we can help you do this, whether it's through storage solutions, infrastructure, AI services, scalable computing, data analytics, and so much more. Enterprise are after smart, easy, and scalable business solutions. A lot of these tools on GCP are there so you can focus on your core business mission, not all these auxiliary functions. So, for example, if you have complex business tasks, the cloud helps you deploy, develop, and scale. You don't have to worry about infrastructure management, system updates, all of those things. Maybe you have data in several different sources that you need to use in a streamlined fashion. And then, last but not least, machine learning. By leveraging our AI platform or our pre trained models, you can incorporate machine learning into your application without having to get a PhD in this field. We just want you to focus on the problem that you're actually trying to solve and nothing else. So, these are the four trends that we're actually seeing in this space. We're going to demo an expense report application backed by machine learning and running on Google Cloud. So now let's actually dive into the specific products that we'll be working with. So let's start with documents. So some of the most important data in companies isn't actually living in databases, but rather in documents. So think about every time that you've had to file an expense report. Nearly all business processes either begin, include, or end with a document. So this is where Document AI comes in. This is a platform that we launched to GA earlier this year in April, and it helps you turn your unstructured content into structured data. You know, there's a lot of important business information in PDFs and images, and these formats aren't actually easily consumable to extract data by a computer as it is. So this is what we actually call dark data. So data that companies have stored for either compliance reasons or something else, but you aren't actually harnessing yet to help decision making, help customers, or make better business decisions. And this is what Document AI is there to help you with. So there are lots of different ways that you can use Document AI. First, we have generic Document AI. So we actually have a toolkit of OCR. We have OCR trained for typed forms as well as handwritten forms. This OCR is powerful. And then we even have something called the form parser, which will understand any form that you feed it. It'll understand the question and answer nature of that form and feed it back to you key value pairs in a JSON format that are much more easy to use than sort of doing that parsing yourself from OCR. Then in the middle, we have specialized document AI. So we have trained several models on the world's most common business form types you can leverage into your system. This is going to be the focus of our talk today, but let me also talk about custom document processing. So we also have tools in our toolkit that you could train a model on your proprietary business form types so you can ensure accuracy. So, specialized document AI. We have different solutions optimized for different industry use cases. So, let me talk about them. First, we have lending document AI. So, this is a set of specialized models for forms such as W 2s, W 9s, bank statements. All of these are different pieces that you'd have in a typical mortgage packet. So, using this solution, you can streamline data capture and all of the different steps that need to happen in a mortgage process to make it faster. Then in the middle, we have procurement document AI. So this covers invoices, receipts, utility statements, and more. And this is what we'll be demoing today. But before we get there, let me talk about what we just launched at Next this year, contracts document AI. It's been said that contracts can be some of the most important business documents that you have. So we've trained models to extract key pieces of information that you can then use to make important decisions like programmatically understanding how long a contract is valid, things like that. So, what's the magic in Doc AI? It's not just OCR. It's a whole pipeline leveraging the technology that we've been building at Google for decades. So, first we have Doc Prep. So, let's say you upload an image of a wrinkled or coffee stained document. We'll use image tools to fix skew, better enhance the text so data can be more easily extracted. Then we get to split and classify. We want you to be able to leverage your data and the raw form that it comes in. So think about a large PDF packet with several different form types in it. Well, by using our splitting and classifying tools, you can actually identify where these subdocuments start and end and what documents are there, so then you can take those specific pieces of your packet and then feed them through the correct processor. Then we have entity extraction. So this is where we extract those key pieces of information that you need per doc type. So even though you might have high variance doc types, every receipt and invoice might look different, we know that there are pieces of information that are universal to these document types. So for procurement, every invoice is going to have an invoice ID. Every receipt will have several line items. They'll have currency, they'll have total amounts, they'll have tax values. So we've designed a schema per form type that you can guarantee your data will be merged into and returned to you in your JSON response. So this makes it much easier when it's schematized to then either feed into a database or give the pieces of information that you need to a downstream service. Now, let's talk about some more magic pieces. Now we have normalize and enrich. Have you ever been coding with dates and times and had a formatting mismatch? I'm in America and Guillaume's in France, and we use different date-time formats. Well, Document AI will do normalization on monetary, dates, and addresses, so it's more easy to work with whatever style your system is in. Here, we also use for enrichment the Google Knowledge Graph. So the Google Knowledge Graph is a service that powers search as well as several other applications that lets you know contextual relevant information. So let's say on your document you have an incomplete business name or maybe an address that isn't full or correct. The Google Knowledge Graph will supplement this information with the key pieces of information that you could then find, in a search query. Then, last but not least, we know with these critical business processes, you have no room for error. So, with the human in the loop platform, you can select a confidence threshold where you can have a document reviewed if certain keys don't meet a certain value, say 95, 98% confidence, or if the whole document doesn't meet that confidence threshold. So, I know we went through that really fast, but now let's work on taking this API and turning it into a full-fledged application. So I'm going to hand it over to Guillaume to tell us how we're going to do that.
Thank you, Anu. Anu described the big piece of the puzzle, which is where most of the smarts are. But we'll need some business logic, some business processes to integrate everything together to create a full-blown useful application for our end users. In a short moment, I'll show you how we use Document AI, cloud functions, and workflows to craft a smart expense report solution. But how are we going to do it? Well, we are going to use Google Cloud serverless solutions for business logic, thanks to cloud functions. What is serverless, and why should we use that instead of your homegrown servers or virtual machines? Serverless solutions allow you to focus on your application and not on infrastructure management or provisioning. Serverless products like Cloud Functions are fully managed environments developers can use to easily deploy and scale their logic without hassle. So from a programming model perspective, we usually create stateless services-based architectures, which scale more simply. And last but not least, since the scaling is handled by the platform for you, we also apply a pay only for usage pricing model where you pay really proportional to the actual usage of your application. Cloud Functions is a bit like some cloud glue for a more programmable cloud, tying various useful services together, reacting through events flying through your system. There are language runtimes available for all major programming languages, whether it's Node.js, Python, Java, and more. Cloud Functions react to events like incoming HTTP requests, background events from the cloud, like a new file stored on cloud storage or a new document in Cloud Firestore, our NoSQL database. And you can easily deploy small units of business logic on the platform from the console, the Google Cloud Console, or from the command line as well. Applications are often composed of several services or APIs that you can call in turn to create the overall business process, like invoking the Document AI API or calling Firestore to store some structured data, as well as some cloud functions to implement some logic, like finding the right information from the Document AI's output. For orchestrating those APIs and services, we can take advantage of Google Cloud Workflows. Workflows is a solution to orchestrate Google Cloud and HTTP-based API services, including third-party. It doesn't have to be something solely, hosted on Google Cloud. And to tie them into serverless workflows. It's about automating complex processes. Workflow is a fully managed service requiring no infrastructure or capacity planning. It offers fast scalability support, scaling down to zero when not used, and a pay-per-use pricing model, a per step in the workflow, per step model. And last but not least, for the developer experience, it deploys instantaneously. You have a YAML-based declarative language. You can also use JSON, actually, with variables, with expressions and formulas. You can apply some conditional logic for conditional step execution and branching into your workflow steps. With what else? Built-in JSON parsing when you need to parse the API output from the API that you call, with error and retry logic when an API fails and you need to retry and call it again, and various other useful built-in functions. There's also built-in authentication for Google Cloud APIs and services. So, for example, services that would be hosted on Cloud Run or Cloud Functions are pretty much transparently authenticated when called from the workflow definition. It executes workflows with the reliability required for enterprise and line of business applications. Workflows offers fast scheduling of workflow executions and transition between the various tasks and steps, and also predictable performance with no cold start at all. In terms of pricing, as I said, it's a per step execution pricing approach. So let's have a look at a demonstration. It's an expense report application. We'll use Document AI for the smart parsing of the receipts, Cloud Functions for some logic for invoking the workflow, calling callback endpoints for the manager approval, or also transforming some light ETL for transforming some complex data into simpler data structure that will store in Cloud Firestore as structured data. And of course, workflows to orchestrate the whole process. So let's have a look at the demonstration. Here is our expense report application. As an employee, I have access to this page where I can select and upload some receipts to create my expense report. So let's click on the select button. I'm going to pick a couple receipts. Then I'm going to click the submit report button. So the receipts are being uploaded and the report is submitted, and now it's already in the processing queue. It's going to be handled by Document AI, who's going to look at the items, the line items, the supplier, etc., that are recognized in those receipts. Now let's have a look at the administration page, which is the page that managers will be able to look at to accept, reject, approve expense reports. So here we already have one report waiting in the queue. So the previous report that was submitted contained 2 receipts. I can click to see the details. So there's the Braintree restaurant, the Raphael restaurant, and I can see some details of what was ordered, the price, the total amount, the currency, and Document AI is able to do some data enrichment. So I could potentially see the knowledge graph information, for example, with the details about the address of the restaurant. Then, if I'm happy with this expense report, I can just click on Approve, or if I'm unhappy, I can click on Reject. And all those actions are actually going through the workflow definition. And for example, now I can see that my report came into the approved section. That's the one that I just approved. And yeah, the one I had submitted just a few seconds ago arrived. This time the vendor wasn't recognized, but at least the amount, the currency, and the details were handled nicely. So let's have a look at how it's done under the hood. So first of all, I'm going to show you the workflow definition. So as I said, everything is going to the workflow or through the workflow. So whenever there's an action in the UI, it's going through some cloud function invoking the workflow. So for example, here I'm preparing my workflow definition with some variables, but let's have a look at this one. With workflows, you can call REST APIs, any API, whether it's from Google, your own APIs, or it could be third-party external APIs. But here, I'm not calling Document AI directly, I'm actually calling a connector, which is a dedicated wrapper around the REST API for Document AI. And what's great with that is that although invoking the batch process of going through all the receipts, I don't have to handle the waiting, logic, queuing, etc. I just need to say, okay, I'm submitting all those receipts. They are here. You'll find everything there. And I'm interested in the results. Please put the results of the processed annotations in cloud storage. So in a few lines, we're able to call Document AI. And then, so either it's working or there's an error potentially. So we might branch in different places of our workflow. In fact, by the way, you can see the visualization of your workflow on the right side here. I'm updating Firestore to explain what the status is. But here, if the parsing succeeded, we can have a look at the annotations, the results returned by Document AI. And we have a little cloud function here that's going to parse the JSON file generated by Document AI to find the relevant details I'm interested in. So this is this function, process annotations. And what it's doing here is that I'm going to tell this cloud function, okay, let's have a look at the files in this storage bucket where the JSON generated by Document AI is located. Then I'm going to go through all the files. Each receipt has a file associated with it. So I'm downloading the file locally and I'm parsing it with JSON. And then I'm going to hunt for the interesting fields. For example, I'm curious about the supplier name. I want to learn about all the line items that are available, each line. Okay, I ordered a pizza, I order some drink. I'm also interested in the total amount of money, but also the currency, because it's important to know which currency was used. And then I'm creating this summary, and then I'm storing that in Firestore. All the metadata, I'm storing that in Firestore. And let's go to Firestore, where I can see the results here. So what's stored in Firestore, that's things like the status, whether here it's awaiting validation, But here I see the line items for this first receipt, the line items for the other receipt. But if you come back here, you'll notice that the report is awaiting validation because we want the manager to approve or reject this report. So that's why we have the approve and reject button. But what's happening here? We've got the workflow that is running, but there's a very useful feature in workflow that's called callbacks. A callback is a way to wait for some external input, whether it's a human input, here it's the manager that's going to approve this report, but it could be some external system that is going to call back the workflow to continue its execution. And let me show you this part of the workflow. I'm creating a callback here. So I'm saying I'm ready to receive a post, an HTTP post on the URL that workflow is going to generate for me. And then I'm also going to await for the workflow to be, the callback to be called. So this is here, await callback. And I'm waiting just an hour, but I could wait longer, potentially up to 1 year. And then either it works or not, it's rejected, or perhaps there's an error and I update Firestore with this information. And that's where here again, I interact with Firestore to store the approval or rejection. So that's about it for the demo. So to recap what you saw in this demo, here's an architecture diagram that sums it up. So we have the two web pages for the employee submitting the expense report and for the manager approving the report. So the first step is to upload the receipts into cloud storage buckets. We'll do that thanks to Firebase storage, which uploads the document into cloud storage buckets. Then again, from the UI, from the employee view, we'll go through a cloud function that is going to invoke workflows to create an execution and start the execution of our workflow. What workflow is going to do? Well, it's going to store some data about the expense report that's been submitted, but then it's going to invoke document AI and let document AI fetch the receipts from cloud storage, analyze the receipts, and then store the result into a JSON file in another bucket, a cloud storage bucket. Then the workflow is going to call another function whose job is going to actually go through the JSON data and pick up just the right information we're interested in, line items, supplier name, amount, total amount, currency, etc. So we've got the data. In the manager view, the manager will be able to click on either buttons, the one approving the expense report or the one rejecting the expense report. And we'll go through the callback URL from this web page. We'll call back into the workflow through a cloud function to continue the execution of the workflow and store the result approved or rejected in our Cloud Firestore database. And that's about it for this architecture diagram of our expense report application. So thanks a lot for your attention. We'd like to encourage you to have a look at those few links here to get started on Document AI, workflows, and cloud functions. We are really looking forward to hearing from you about what you're going to build next with those technologies.
Yeah, so you can take a look at the source code of what we showed today. Guillaume and I had a lot of fun building this. We used Node.js with all of these services. We've published the code to GitHub. Let us know what you think. Tweet us what you're going to build or what you're excited for, and let us know how we can help.